Hi to everybody, and welcome to our webinar about the serverless data collection with Amazon Kinesis and AWS Lambda. My name is Roberto Turrin. I'm Head of Technology here at Cloud Academy, and with me there is...
Hi, welcome to everybody. I'm David Santucci. I'm Data Scientist at Cloud Academy.
Thank you, David. Our webinar today will cover a real case that we have faced with in the last month, and so we are going to share our experience with you. I will present you a brief introduction of our problem. I will give you some details about the architecture, and then I will leave David presented how we solved this problem using several services of Amazon. In particular, we used the Kinesis stream, Amazon Lambda, and we configured that ladder queue for Amazon Lambda. And in the end, we will draw some conclusion and leave some open point for future tasks. We will also cover some question and answer at the end. So let's start with our problem. We, as you can imagine, have several data that we collect from different sources, and one of our problems is to collect this data that we trigger to, and these are collected from different sources such as backend applications, for example our website, some front-end application, for example there are some JavaScripts that trigger events, and in the end there are also some mobile applications. There are also some other different sources, but just to make you some example about the kind of application we face with. And when we have this event, we need to collect them and store them to different destinations. Examples of destinations are our data warehouse, where we build on top some analytics, for example, but we also use some third-party services such as HubSpot for our customer, Mixpanel, Google Tag Manager, and so on. And so our needs is to have these events routed from our multiple sources to our multiple destinations. And our main goal is not to lose this data and to have a robust architecture in order to have this data collection working properly. So in this webinar, we will face with this problem, that is having this data collection pipeline, and we will face the problem using a serverless architecture. So we invite, I would like to involve everybody that has a basic knowledge about AWS services, and in the end we will also give a very brief introduction about all services that we will mention, but we will not cover all these services in details. Among the services, we will use some features of Kinesis stream, of AWS Lambda, some features of SQS. We will mention just briefly S3 and Amazon API Gateway. And just for some conclusion, we will compare our solution with StepFunctions. So here we are. That's our architecture that we want to share with you. And in the top left corner, we have the sources of our events. And there is a backend, there is a mobile, and there is a front-end application. In front of these event sources, we put a Kinesis stream. And there are two ways we connect it to Kinesis stream, and two ways that is our events are sent to Kinesis stream. One is by using directly the Kinesis producer library, which is a client that connects directly to Kinesis stream, and our backend sends events to the Kinesis stream using the Kinesis producer library. On the other hand, our mobile front-end application couldn't use the Kinesis producer library because it wasn't available for that use cases, and so we had to put in front of Kinesis stream Amazon API Gateway in order to have an endpoint. And one event per time is sent to a Lambda function that is in charge of routing this event to other Lambdas. And each Lambda in the end is connected to a destination. There is a Lambda that is connected to the data warehouse. There is another Lambda function that is connected to some other third-party services such as HubSpot or Customer I/O, just to make you an example. And starting from this architecture, I will let David drive you through the single parts of the architecture, and we will also see how to configure single components such as Kinesis stream or Lambda in order to make to create this data collection pipeline. Please, David, help us in this configuration.
Thank you, Roberto. Let's see the architectures in detail. In the top left corner, you can see the event sources. There are several blocks represented, one for each different kind of data source. As you can see in the diagram, the backend directly sends events to the Kinesis stream through a KPL, that stands for a Kinesis producer library, and then there are other block such as mobile or front end that send events to Kinesis stream through another module that's an Amazon API gateway that works as a REST endpoint. An example of a backend generated event is, for example, a user that performs a login inside our application, or a user that requests a report, and then the KPL works as a producer and sends the events to the Kinesis stream. On the other side, an example of an event that is managed by the Amazon API gateway is, for example, a page scroll that is tracked from our website homepage, or just to do another example, or a button clicked on our iOS or Android app. So let's do something practice and look at the AWS console. So I'm in my own account. You can look at all the AWS services. We can find Kinesis. Yeah, there. You can click at Kinesis, but you can find it down in details below. So let's create a new Amazon Kinesis. As you can see, there are several services, different services in this panel, but we are interested in the last one, that is Amazon Kinesis Streams. So go to Kinesis Streams. We already have a stream, but we can create a new one. So we can create a new stream, and we can name it data collection pipe. Okay. Then you can set the number of shards. By now we can set it to 1. Default is okay for us. So create the stream. Okay. Just done. Now you can see it is the data collection pipeline that can receive events from different sources. So what's the advantage to use this kind of solution? We can collect and process large streams of data and collect them in real time. So there are a lot of scenarios, of very useful scenarios for using this kind of solution. And typical ones are manage different producers that pushes their data feed directly into this stream, or collect a lot of data, for example, a data log or real-time analytics and metrics. This is a perfect solution if you want to create a pipeline. And then another advantage is that you can use other AWS services and connect them directly to our stream. So we have some tips for you. For example, as you can saw, we used an API gateway as the entry point for front-end and mobile. This is very useful, and you can let you manage a RESTful endpoint for this stream. So as you can see, we use only one single shard. Then you can increase if you have more traffic. And another suggestion by us is to use to send events one by one to avoid data loss. Now we describe the architecture that we use to for conditional routing. As you can see, routing Lambda function is in charge of the conditional routing to destination services. In fact, based on the event name on the routing rules defined on an external file on S3, the event is either discarded or allowed for specific services. This function implements a retry strategy and is triggered by Kinesis streams directly. Now we need to synchronize data on third-party services into our architecture. They could be external providers such as Google Analytics, Mixpanel, HubSpot, or everything, or another third-party service. For each destination service, there is an AWS function is invoked asynchronously, and this single AWS Lambda function implements a connector that provides the logic to connect to the destination service, such as HubSpot, and a retry strategy. So if event saving fails, it retries for a specified number of times, an exponential delay. So let's see how to implement this kind of solution directly on AWS console. So we go outside the streams panel and we search for Lambda here. Okay, we create a new one. Okay, as you can see, there are a bunch of blueprints. We can search for a stream one. Okay, Kinesis stream. Okay, perfect. This kind of Lambda really has a Kinesis trigger. So we have only to select our stream, configure the batch sizes. The batch size, as I said, the perfect number for us is 1, and is a good solution because we avoid data loss in this kind of way. And then you can select a starting position, and we select the trim horizon. This is a common solution if you have to manage events in the pipe like a queue, not like a pipe. So you can enable the trigger just now, and then click on next. In this configuration panel, you can create the Lambda, and we call the Lambda data collection router. Okay, we can select several languages, for example, Python. And then, very important, we have to select an existing role, IAM role. Okay, we already have one. And this is the Lambda basic execution. Okay, that's already done. So next, and we have a summary of all configurations. It's okay for us, so we can create it. Let's wait a few seconds. Okay. Now we have a trigger enabled, and when a new event comes from Kinesis stream, we have already in our Lambda function to be processed. So our tips. as usual, enable Kinesis stream as a trigger for the AWS services, as you can see. And the S3 has been used as a repo for our routing rules, and we used a JSON file for this. And very, very important, we see we use the invocation of other Lambda asynchronously. A very important tip is to always create aliases and versions for each functions, and use environment variables for each configurations. Let's see in the panel. So now we just created the route rule Lambda. Then we have to create new Lambda functions, and for this purpose we use black function. No trigger is needed. So we can create a white Lambda function, one for each services we have to connect. So for example, we can connect Google Tag Manager, or maybe HubSpot, or our data warehouse. So this is an optional description. We have to select our favorite language. Okay, as usual, an existing role. Pay attention here. We try to select our Lambda basic execution, but if you try to go next, okay, you have the default settings, and then we can create this function. Okay, how to trigger this function? We can write inside the code the arrival rules a specific function that trigger the correct Lambda function, basing on the rules written from the S3 routing rules files. Okay. Okay. As you can see, we have another interesting thing to do is to set a dead letter queue. A DL queue is a very useful tool from AWS that allows us to avoid event loss. Lambda automatically retries when it fails when it fails to execute an asynchronous invocation. So it's very useful to configure a DL queue. Let's try together. So go again in the AWS console, and then try to create a new SQS. Okay, get started. Okay, write down the name for us. For example, data. Use this for data warehouse, so we can call data warehouse DLQ. Okay, so default settings are good for us by now. So we have only to create a queue. The queue is just created. Then you can come back in the Lambda console, select our service connector. So in this case, the data warehouse connector, and configure the TLQ in advanced settings. There. We created an SQS, and then we search for our SQS, data warehouse DLQ. Perfect. Oh, there is a problem. We have no permission to send message for this SQS queue. This is due to our a lack of permission. So we have to go there, role. We already have a role for this kind of permissions. So we can search for SQS, and we have a Lambda basic execution that includes permission with SQS. Okay. Good. Now we can save it. Perfect. Okay. Perfect. Just a while ago, we discussed about our retry strategy. With DLQ, we can handle this kind of errors, and in the case of multiple failures, the event is stored to a SQS queue using the dead letter queue. You can recover the complete list of message in the DLQ using another AWS Lambda function or manually. I think, in conclusion, this kind of serverless architecture is a good solution, because our goal of scalability is reached, and we have built an architecture that prevents data loss, and we have the full control on each module of each single connector to our third-party services. And last but not least, we have not expensive costs for the development and the maintenance of the architecture.
Thank you, David. I would like to give you some more suggestions for this data collection pipeline, and to explore some open points that we already thought about and we didn't have the time to explore. First of all, in order to improve the control on the architecture, we are planning to create a dashboard on CloudWatch that will be created with your own KPIs. So the suggestion is for you to monitor for example, the size of the SQS queue used by each Lambda, in order to monitor whether there are events that have been discarded by some Lambda function. And so when they are discarded, they are moved to this dead letter queue. And if you have a monitor, you can set some alarm on CloudWatch and be notified in the case there is a peak of events that are moved to this dead letter queue. Furthermore, you can monitor for sure the execution time of each Lambda function and the execution time of the Kinesis stream service. That is a good KPI for you also to understand and to forecast your costs, and basically because each Lambda cost as the time you have used it. So if each execution of your pipeline for each event you send to this data collection pipeline takes to you 500 milliseconds, that you will pay for these 500 milliseconds. And so if you monitor these events using, for example, CloudWatch dashboard, you can forecast this cost. And another open point that we are going to explore is to attach in front of the Kinesis stream Kinesis file pose, and can be, for example, used for backup to S3, just to make you an example of a use case. So connecting connecting both a Lambda function and a Firehose service to the Kinesis stream, we will have both a real-time routing of the events towards our destinations and a backup for each event. Actually, Firehose will aggregate events into groups of multiple events. It depends on time or on the size of the events. At minimum, we will have one aggregation per minute, and so for each aggregation, we will store an S3 file on Firehose. This is something we are going to experiment. What else? Since that you have saved your events to your dead letter queue, questions that arise is how can I use these events? Well, you can write a simple script that manages these events, that reads from each SQS queue, processes the events, and sends the events back to the data pipeline. Just note that if the event has been discarded, maybe there is a reason. And so before starting an automatic script, we suggest you to analyze the event discarded and understand the reason why they have been discarded. It is very high the probability that if you send that back to the data collection pipeline, and it will be discarded another time because there is some problem, for example, with your destination service. Another point is that in addition to add, for example, file host in this pipeline, another destination might be a Kinesis Analytics, which is another service of Kinesis. And this could be, for example, used to implement some analytics, for example, anomaly detection on the events, and so understand that there is a peak of downloads from a certain region in the world, and so we need to stop this kind of events, and so we need to trigger an alert for this. And finally, if you are a little bit familiar with StepFunctions that have been released by Amazon recently, well, you can see that most of what we have created is can be replaced with a step function. The reason why we didn't go towards this direction is that it's mainly a matter of cost. Step functions for our architecture and for our scope was much more expensive than implementing this solution. And in the end, we wouldn't have used all the functionalities of step functions. And so it wasn't a cost that was worth it to spend for our purposes. So we are going to make some proof of concept about step functions in order to understand on a stage environment whether our forecast costs can be are different from the reality, but in the end I think that the cost of this solution is not worth it for our use case. So this drives me to the end of our webinar. Let me see if there is some questions to answer to you. Well, one question is how to enable security groups for Lambda. Well, I think that going to the console, we can simply select in the configuration. There are different roles, and you could set VPC.
Yeah, you can create a custom role, and then you select the custom role from existing role. So each role can be put inside a specific group, and then the single role can be selected from the configuration panel.
Yeah, and from here, if you have a VPC and you want to put your Lambda function within your VPC, you can set this VPC and have your function working from your network with all the permissions that are enabled within your private network. Yeah, from here you can select your security groups as well, and there it depends on your policies. Another point is how our try strategy works. I don't know if David wants to.
Okay, let me introduce the issue. So when an event saving fails, the Lambda function that has been built for the specific connector, retry for a number of time with an exponential delay. It means that the function that invoke asynchronously the connector retry, and for a specific number of time recall again the same Lambda function. If this retry fails again, the DLQ take effect, and then we can find the event on the SQS linked to the DLQ.
Yeah.
There is another question?
Yeah, just to answer to another question, I would like to give you an example of why we need live streaming, where we have different dashboards that are monitored at real time. And so we monitor, for example, the consumptions of our products at real time, the consumption and the usage patterns of our pages at real time. There are different KPIs that we monitor at real time.
We talk about logs, for example, server logs.
Yeah, for example, server logs. And so we need to propagate this information as soon as possible. And instead of using some batch processing, we are going with this architecture to have this live streaming of data. Of course, it's pseudo live streaming. I mean, there is a minimum delay, but it is tolerable, and we can still process and compute these events at real time, aggregate them, and, for example, extract metrics that can be used for at real time. Also, the example of anomaly detection that I mentioned earlier, that can be enabled by this architecture, and the live streaming is a good property that we love to have.
Yes, of course.
Okay, so
there's another question?
Let me grab another questions.
Okay. Oh, yes. Yes, of course. The question is it possible to test by sending some live streaming of data and verify events in CloudWatch? Yes, of course. There is, you can configure your data collection pipeline directly from the CloudWatch console. So, CloudWatch console, okay. Here? Okay. Then you can create a custom dashboard, and of course you can create a data pipeline with connecting the DLQ. It's very useful, and the all Lambda functions too. So retry and fails. But in order to have a quick sight of the current status of our Lambda, we can go there. Then you can select our single Lambda and then monitor the execution. So there is a very useful dashboard, and moreover there is a very new dashboard that is iterator age. And here you can see, for example, how long the message has been processed. So from our queue. So I think it is very useful. If you need something more custom, I suggest to use, of course, the CloudWatch configuration. But for a quick view, it's perfect to use the monitoring tab here inside the Lambda function itself.
Okay, thank you again, David, and thank you to everybody for your attending. I think that if you have any other curiosity or question, you can post to cloudacademy.com/community. We will post it on your chat right now. And so if you have any other question or whatever, just write there, and we will be happy to reply to you.
Thank you.
Thank you again, and have a nice day. Bye-bye.
Bye.